Hello, this is TCG and welcome to the fifth lecture on CompTIA Security Plus 601 exam. Let's get started. Protecting data. Sometimes data can be more important than raw capital for a lot of organizations. This data can exist on hard drives, archives, or stored on cloud storage devices. Data sovereignty. It refers to the fact that data is subjected to laws enforced by the government, such as GDPR in Europe or HIPAA in the US. It is the organization's responsibility to ensure compliance for these laws when data is transferred, stored, or processed. Data masking is a process of obfuscating sensitive information in order to protect it from unauthorized access, but at the same time being able to use it for verification and testing purposes. It is often used in testing and development, and also you might have noticed that when entering credit card details or bank information, they try to obfuscate all data except the last four digits. Data encryption is a process of using algorithms and keys in order to convert plain text data into ciphertext. This data can only be used by authorized users who have the proper algorithms and keys to decrypt the ciphertext into plain text. Diffusion, also known as the avalanche effect, occurs when a small change in the plain text translates into a huge change in the ciphertext. This is very critical because it makes pattern less discernible for the attackers, making it difficult for attackers to decrypt the ciphertext. Data at rest. Data at rest refers to the physical hard drives, SSDs, or backup tapes where data is stored. Protecting data at rest involves encryption, access control, and physical security measures to prevent unauthorized access and ensure data integrity. Data in transit refers to the data that is actively being moved from one place to another across the internet or across a private network. Data in transit is susceptible to man in the middle, eavesdropping, tampering, and interception, which is why we use protocols such as SSL or TSL to prevent eavesdropping and man in the middle attacks, and VPNs to prevent interception and tampering. Data in use refers to the data that is actively being used by a user or an application and is currently being stored in the RAM. This data is a huge point of attack for attackers since this data is not encrypted by any protocol, which is why securing data in use is a critical component of data security. Tokenization. Tokenization is a process of replacing sensitive data elements with non-sensitive equivalents called tokens. Tokens cannot be mapped to the original data without the proper data server, which is why it is useless for attackers. Tokens or tokenizations are commonly used in payment processing and protecting personally identifiable information or PII. Information Rights Management or IRM. IRM controls how information is used and distributed. This information can be documents, emails, and other digital files that contain sensitive information. Since this information is sensitive, it needs to be protected. For Windows, we use XML paper specification or .xml files to protect these documents from unauthorized access. Data loss prevention. DLP or data loss prevention is a set of strategies and tools designed to prevent unauthorized access, loss, and destruction of important data. DLP is often a compliance mandate by the customers, stakeholders, and the government. DLP systems are comprehensive solutions used by organizations to monitor, detect, and block potential data leakage, data manipulation, and data destruction. USB blocking. USB devices can be used to install malware onto a system without the user's knowledge, which is why we need to prevent data transfer via USB drives. This can be achieved via device control policies, encryption enforcement, logging, and monitoring. Cloud-based DLPs. Nowadays, a lot of organizations are moving to cloud based environments because of their flexibility and the scalability. Security of data in a cloud based environment is the mixed responsibility of the cloud service provider and the organization that is using the services of the cloud. The organization has to manage the proper access to resources, while the cloud service provider has to make sure that all the policies are being followed. DLP in email. DLP in email focuses on preventing the accidental or intentional leakage of sensitive information through email. Email is a common vector for data breaches, so securing it is essential. A DLP system that works on an email checks for both inbound and outbound emails for any information leaks. Managing security. Managing security involves a holistic approach that addresses various facets of protecting information and services. Here are key aspects of managing security effectively. Geography. We need to ensure data compliance with local data protection laws such as GDPR in the European Union or CCPA in California, and so on. Organizations must know where data is stored and processed and ensure it meets regulatory requirements of that place. We also need to consider the placements of networks and servers in such a way that it gives us the best performance and lowest network latency. Response and recovery control. In the case of an incident, organizations need to be able to act swiftly and without delay. This is where an incident response plan comes in. Organizations need to develop and regularly update a comprehensive incident response plan that outlines the steps to be taken in the event of a security breach, including identification, contamination, eradication, and recovery. After an incident has happened, it needs to be documented, and the organizations need to plan for the recovery of the affected systems. This is where a disaster recovery plan comes in. Since downtimes are associated with financial losses, a disaster recovery plan can help us switch to backups or failover systems in an instant. An SSL or TLS proxy is a software or a device that intercepts and decrypts SSL or TSL traffic to address security, compliance, and performance issues, re-encrypts it, and send it to where it was supposed to go. SSL TLS inspection. It involves decrypting and inspecting SSL TLS traffic to detect and prevent security threats that may be hidden within encrypted communications. This also leads to a privacy concern, as all the data that is being passed through here is being checked by a system or a device. Hashing. Hashing is a process of converting data into a fixed size string of characters called digest. Hashing is used to verify data integrity, store passwords, and digital signatures. Hashing has the avalanche effect, so a small change in the initial plain text can lead to a huge change in the hash or the digest. We can use hashing to store passwords. Since hashing only works one way, we can convert a password into a hash, but a hash can never be converted back to a password. API security. An API, or an application programming interface, is a service that is used to communicate between two different systems or softwares. APIs are vulnerable to on-path attacks and API injection, which may lead to a DDoS attack. To prevent such issues, we use authentication and web application firewalls. Site resiliency. Site resiliency involves preparing an alternate location where an organization's IT operations can continue if the primary site becomes unavailable due to a disaster or other disruptions. There are three main types of recovery sites: hot sites, cold sites, and warm sites. Hot sites are fully operational and ready to take over organization's IT operations almost immediately after a disaster strikes. They offer the highest levels of preparedness and typically include all the raw data and all the infrastructure, which is a direct copy of the main servers or the main location. They are fast, ensure business continuity with minimal disruption, and ideal for mission critical operations. They cost high due to the need for duplication in infrastructure and continuous data synchronization. Cold sites. Cold sites are basic data centers with infrastructure but without active hardware or data. They offer lowest level of preparedness and are the most cost effective. They have no real data and hence it requires a longer time to set up for the same. Warm sites. Warm sites offer a middle ground between hot and cold sites, balancing time and recovery costs. They include a partial setup where they have some hardware and software installed and may have some critical applications pre-configured. Data is periodically synchronized, though as not as frequent as in hot sites, resulting in some data lag. Warm sites can be made operational within hours to a few days, providing a reasonable balance between speed and cost. Deception. Honeypots. Honeypots and related technologies are crucial tools in cybersecurity designed to detect, deflect, and study unauthorized use of information systems. By setting up traps that mimic legitimate systems, security professionals can gather valuable intelligence about potential attackers and their methods. Honey files. Honey files are decoy files placed strategically within a network or endpoint to attract potential attackers. These files appear to contain valuable information but are actually traps to set up to monitor unauthorized access. Some of the good examples of honey files are robots.txt files in every website. Honeynets. Honeynets are networks of honeypots designed to simulate an entire network environment. They provide a more comprehensive trap for attackers, allowing detailed observation on their tactics and techniques. They are isolated from the main network, making the main network safe from any attacks that the attackers use. Fake telemetry. Fake telemetry involves generating and deploying fictitious systems and network activity data to deceive the attackers. This technique can mislead attackers and make it more challenging for them to distinguish between legitimate and decoy systems. Cloud services. Infrastructure as a service. This is the base service that a cloud service provider provides, which involves the base hardware and some network security. In this service, organizations install their own OSs and applications and manage the middleware on their own. This provides the organization with the most flexibility, but at the same time, it requires the most amount of work. Platform as a service. In this kind of service, organizations do not have to manage the middleware and the OS, making it easier to develop, run, and manage applications. At the same time, it provides less flexibility than infrastructure as a service. Software as a service. In this kind of cloud service, the cloud service provider handles all maintenance, upgrades, and security of the application. It is also most easily accessed by a web browser anywhere in the world. Software as a service provides the least amount of flexibility, but also requires the least amount of work. Everything as a service, or XaaS. This kind of service encompasses various service models such as IaaS, PaaS, SaaS, networks as a service, NAS, and database as a service, DBaaS. There might be more such services that can be added on in the future. MSPs or managed service providers. MSPs offer management and maintenance services for cloud infrastructure, helping organizations optimize and secure the cloud environments. They handle the infrastructure management, security and compliance, backup and disaster recovery, and performance monitoring and optimization. Now let's talk about on-premises systems. Using these systems can give us full control over the infrastructure and data, allowing us to implement custom security measures that are effective and efficient for our purposes. On-premises systems involve high upfront capital expenditure, which involves the hardware itself and the personnel required to handle the infrastructure and data. When we talk about off-premises systems, they are managed by the cloud service providers. Hence, the infrastructure is abstracted from the organization. This involves a shared responsibility model so that all the cybersecurity of the data and the application is the shared responsibility of the cloud service provider as well as the organizations. When we talk about a cloud service, we mostly think of an operating expenditure, which is a pay as you go model. Cloud services demand lower in house management effort because the provider handles maintenance of the systems. Cloud deployment models. Public cloud. A public cloud is where multiple organizations or multiple customers of a cloud service provider share the same physical architecture or the same hardware and are separated by a virtualization. A private cloud is when a cloud service provider dedicates their resources and hardware to provide cloud services for an organization. A hybrid cloud is a combination of public and private clouds, providing flexibility and optimized cost management. It also enables data and application portability. A community cloud is when various organizations come together and set up a shared infrastructure for specific community or industry. It involves a collaborative effort with shared concerns. For example, a government or healthcare clouds. Edge computing. In edge computing, the data is processed at the edge, that is locally, as compared to sending the data to a centralized data server. This reduces the latency, conserves bandwidth, and improves real-time data processing capabilities. This also improves privacy and security by keeping sensitive data local. Fog computing. Fog computing, as compared to edge computing, involves a more distributed approach. In fog computing, we have various fog nodes, which are routers, gateways, or dedicated servers located between the edge devices and the central cloud. All the data is distributed in these fog nodes. Fog computing is very much compatible with large-scale IoT networks. Something to note when using fog computing is that we need to address security and privacy concerns in a distributed environment. Designing the cloud. Thin clients. Thin clients, also known as desktop as a service, are lightweight computing devices that do not do any processing of their own, but rather connect to applications and data hosted in the cloud. Virtualization. Virtualization is a way to run multiple operating systems or virtual machines run on a single physical server. Hypervisors are the software that creates and manages virtual machines. One advantage of these virtual machines is that they're isolated from each other, so that if one virtual machine is attacked, it does not harm any other virtual machine on the server. Virtualization also helps us maximize resource utilization and flexibility. Application containerization. Containers are lightweight and portable units which we use to package applications and the dependencies. All containers are independent of each other and they run consistently on all devices. Microservices and APIs. Microservice architecture breaks down applications into small independent services that communicate via APIs. This architecture is resilient, as in failure in one service does not affect the whole application. It is easy. It helps us in easier updates and faster development cycles. It is often used in large-scale applications such as e-commerce platforms, social networks, and more. Serverless computing, also known as function as a service. This service is not truly serverless, but we call it serverless because all the works behind the scenes is abstracted from the users. Functions are executed in response to events such as HTTP request, file uploads, etc. This kind of service involves a pay per use model and scales automatically. Virtual private crowds or VPCs and transit gateways. VPCs are cloud services that are designed for specific service or domain. A, an organization or a service may have multiple VPCs working for them. And in order to connect between the multiple VPCs, we use transit gateways. Transit gateways secure the VPCs as users use VPNs to connect to transit gateways to gain access to any VPCs. Resource policies. Resource policies define permission and constraints on cloud resources to ensure that they are used securely and efficiently. To enforce such policies, we have IAM roles, which control access to resources based on user roles. We can use it to allow or disallow specific users or applications to use a particular resource. Service integration and SIAM, or Service Integration and Management, not to be confused with SIEM, which we will cover later on. Many organizations nowadays have multiple cloud services, but managing these cloud services can be a challenge, which is why we use SIEM service to manage multiple cloud service platforms on a single screen. Infrastructure as Code, or ISC. ISC is a key practice in modern cloud and DevOps environment, allowing for the management and provisioning of computing infrastructure through machine readable definition files. This approach is crucial for software defined network (SDNs) and software defined visibility (SDVs), both of which enhance network management and security. An SDN is an approach to networking that uses software based controllers or application programming interfaces or APIs to communicate with the underlying hardware infrastructure and direct traffic on the network. SDN decouples the network control and forwarding functions, enabling programmable networks. An SDV gives us dynamic and real-time visibility into the network traffic, allowing us to respond quickly in terms of an anomaly in the network. It also simplifies network management by automating visibility tasks and integrating with other network management tools. Virtualization security. VM sprawl. VM sprawl refers to the uncontrollable proliferation of virtual machines. Organizations create and use multiple virtual machines, but ideal or underutilized VMs consume physical resources as well, which is why unmanaged VMs may not receive regular updates or patches, leading to vulnerabilities within the system. VM escape. Although virtual machines are isolated from the other virtual machines and the host network, by using a VM escape, an attacker can break out of a virtual machine and gain access to the host operating system, offering them potential root access, offering them the ability to install malwares and take away the data from the organization. Secure deployment. In the process from development to production, a lot of vulnerabilities can be introduced on the way, which is why we need to use certain methods and tools in order to prevent vulnerabilities from arising. Sandboxing. Sandboxing involves isolating applications or processes in a controlled environment to prevent them from affecting the rest of the system. This technique is used to test and analyze applications safely. Sandboxing also allows us to use the agile methodology to update and create the application. Building the application. It involves compiling the source code into executable programs. Doing so may cause some vulnerabilities to arise, which is why we use automation tools such as Jenkins and Travis CI to prevent the same. Quality assurance, or QA. QA involves verifying the application and testing the application to ensure it meets the required standards and functions correctly. We use three kinds of tests for quality assurance: automated testing, penetration testing, and user acceptance test. After the application has been fully launched, we need to make sure that we regularly update and patch the application as necessary. We also need to make sure that we scale our hardware devices in order to accommodate the users as necessary. Secure baselines. Secure baselines are predefined security configurations and standards that all systems and applications must adhere to. They provide a foundation for ensuring consistent security practices across the organization. For a lot of organizations, it is a mandate to conduct regular audits in order to ensure compliance. Provisioning refers to the process of setting up IT resources such as servers, network devices, applications, and more in order to be ready to use. Deprovisioning is the opposite of provisioning, where we decommission the resources and return them to the pool of available resources. Provisioning and deprovisioning allows any organization to scale their applications and services as necessary. Provisioning and deprovisioning can also be done automatically or manually. The process of automating provisioning and deprovisioning is called orchestration. Secure coding. Secure coding practices are essential to protect applications from vulnerabilities and ensure their resilience against various types of attacks. Stored procedures. Stored procedures are precompiled collections of SQL statements stored in a database. They help improve performance and security by reducing direct interactions with the database. By encapsulating SQL statements, stored procedures can help mitigate SQL injection attacks. Also, stored procedures can help us reuse code. Code obfuscation is a practice that makes code more difficult to read. This does not necessarily change the functionality of the code, just makes it more difficult for humans to read it. Some of the techniques that we use for code obfuscation are code minification, name mangling, and encryption. Code reuse. If we use existing code from an older application, or we use an older code, it can introduce vulnerabilities to a newer application. Dead code. Dead code is a code that is no longer needed or used, or a code that the program will never reach. Note that any kind of code that is useless to the main application can add vulnerabilities to the application. Input validation is a way of removing the chances of code injection in any form or input field. This makes sure that input field data is correct and within expected parameters. Some techniques that we use for input validation are whitelisting and blacklisting some certain characters or words, and sanitization of the input. Memory management. In older languages like C or C++, memory is not managed automatically. This can cause buffer overflow, which can lead to use after free vulnerabilities and can lead to privilege escalation within any system. Third-party libraries and SDKs. Libraries may or may not cause vulnerabilities. We don't know about any of the particulars of that library, which is why it is recommended to use libraries from reputable sources and actively maintain projects which release patches to prevent the libraries from having any vulnerabilities. Data exposure. Data exposure can be intentional or unintentional, but can lead to the internal knowledge of how the system works leaking to the general public, which is why data must be secured. Version control. Version control systems like GitHub help manage changes to codebase, track history, and facilitate collaboration. They manage changes made to the codebase and is useful for comparing versions over time for security. It can be also useful at times where a new kind of code introduced vulnerabilities to the existing application. So we need to remove the newer version and fall back to the previous version. Exploiting an application. Exploiting an application involves taking advantage of vulnerabilities in software to gain unauthorized access or cause unintended behavior. Understanding common exploitation techniques is essential for both attackers and defenders in this case. Since applications are made for all operating systems have a common base, exploiting one vulnerability in the application can lead to the exploitation of the application happening to all instances of the operating system. By exploiting the vulnerabilities on the application, the attacker can try to elevate privileges and introduce malwares to the operating system. Software diversity. Software diversity refers to the practice of varying software components, configurations, and behaviors to enhance security of the application. The idea is that diversity can help reduce the risk of widespread exploitation by making it more difficult for attackers to create a single exploit that works universally. Automation. Automation and scripting are fundamentals in modern software development process. These practices aim to improve software quality, speed up the development process, and ensure consistent delivery. Continuous integration. Continuous integration or CI is a development practice where developers regularly merge their code changes into a shared repository, triggering automated builds and tests. The primary goal is to detect and address integration issues early, ensuring that the code changes are continuously validated. Continuous development. Continuous development or CD extends the principle of CI by automatically deploying every change that passes the automated tests to a production environment. This practice ensures that software updates are delivered to the users as soon as they are ready without manual intervention.